Hey guys, it's Mr. Sheline here. This is going to be another practice video, extra help kind of video for you guys to watch, this time covering dimensional analysis. So the day before you should have, or at least sometime before, you should have gone through either in class or online dimensional analysis. So remember, dimensional analysis is simply just a way for us to convert one set of units to another, and that's pretty much it. And I just want to emphasize how important this portion of the notes are. We're going to be using this tool, this strategy, for the most part for the entirety of Unit 5 and for a good chunk of Unit 6 as well. And it's something that you use quite a bit in Chem 2. It's something that you use quite a bit in physics. So this is a really, really important skill to have. And one that really, even down the line, and you know, when you do get older, hopefully you'll remember how to do this, and it'll help you when you actually need to use this, because sometimes it is actually pretty useful. Okay. So anyway, okay. So here are the first two problems that we're going to be covering. We're going to be covering these two, and then I've got another two on the other side. So here are those, and and I'll kind of talk about this too as we go along too, but they're in two different kind of formats if you notice it. So and I'll talk about that here in just a second. So here's these sets of problems. So go ahead, write these down, prepare yourself to work on these. And realistically speaking, you should be working on these on your own and then watching me solve these and see if you got it right. And if you got it right, awesome. If you got it wrong, you'll be able to see where it is that maybe you went wrong in your calculations. So, okay, here is the first one. So before we get into it, I do want to mention the setup, because I think it is an important distinction and something to notice. There are going to be problems like this where I'm going to be giving you, 54, and this is 54 inches, 2 miles. So a lot of questions are going to be set up like this while we practice dimensional analysis. And then there are going to be some where it tells you convert this to this, which is for the most part exactly the same thing. And there's actually one that I'm thinking about it that I don't have in here. They're virtually the same thing, but I just noticed last year that I had students that for whatever reason were having difficult times knowing what we're starting with and what the end units we wanted to convert to are or were. So I want to emphasize that, because part of understanding how to complete this is understanding where we're starting and understanding what we need to convert to. So, and that's something I'm going to emphasize in here. So looking at this, we're starting off with 54 inches, and we want to convert that to miles. So I did this in the notes where I was like, oh, that's we're converting this to this. I'm pretty sure maybe it was a different set of notes where I did that, but anyway. 54 inches to miles, so we're going from here to here. So that's what we're converting to and from, okay? So like the instructions, like the steps talk about in the notes, we're going to write down immediately what we're given. So 54 inches over 1. Sorry. Oh, this marker is actually pretty stinky. Jeez. It's like hurting my throat. So we're starting with 54 inches here. And we have to create the first conversion factors. So now there are conversion factors that you can look up online where you go straight from inches to miles. But just so you get the idea, and it's extra practice here, I'm going to show you, we're first going to go with inches, then to feet, then to miles. I'm just skipping yards because realistically speaking, a lot of people, as far as I've seen, I can't think of, I may have a problem or two where we go from yards to miles. But really, I can't think of an application or a time I've ever been like, well, I wonder how many yards are in a mile. It's usually feet in a mile. Okay. So anyway, okay. So my first conversion factor here is going to have inches on the bottom, because this needs to go. These are our old units, and we need new ones. And we're going to convert to feet. This one, just because feet's bigger, we're going to say in 1 foot there are 12 inches. Okay. So those would cross out, and then we would be left with feet if we were to solve for this right now. But we still need to go one more step here and go from feet to miles. And again, just because miles is the larger quantity, it's easier to fit our smaller quantity, our smaller range, or I should say that the smaller range has a whole number in this case, and that's the one that should have, the miles is what we should have as the one here. And so I just know off the top of my head there are 5,280 feet in 1 mile. Okay, so then the feet would cross out, and then we would be left with just miles for our units. 54 times 1 times 1, so that's going to be on top. 1 times 12 times 5,280. Now remember, this is a conversion factor. This is a conversion factor. We don't worry about these. We don't worry about the conversion factors, sig figs, because they are an exact number. We only care about our measurement. That's our inexact number. So our end answer needs to have 2 sig figs here. So it's going to be 54 divided by 12 times 5280, which is going to give us an itty bitty little answer of 8.5 times 10 to the negative 4th miles. Nice. Okay, and we have our answer. So we kept sig figs. We've got proper scientific notation that we got through our calculations in the calculator, and we carried our units. So something I mentioned a bit in the notes, make sure that every single time you've got your correct value and you have your units. When we move on from just worrying about dimensional analysis and we actually apply it to measuring out like chemicals, you have to get in the habit of writing down your value and also your units. And then when we get there, it'll also be units and also your either compound or atom, whatever you're measuring. Okay, or element, I should say, not atom, but element. Okay, so next question. So we're going to convert 840 inches to centimeters. So we're going to start here and we're going to go to centimeters. Okay. So we're going to start here. We're going to write down what we're given, 840 inches. And we're going to write our table here. Now, let's see. Oops, and I got to have my notes ready to go, which I don't. Got to find that conversion table. So our conversion table should have inches, either inches to centimeters, which it does. Yeah, it has inches to centimeters. And not the other way around, but that doesn't matter. So looking at our conversion factor side of the notes, it looks like that we have the number of centimeters that fit into 1 inch. So in 1 inch, there are 2.54 centimeters. Okay. Those will cross out. Inches are gone. It looks like we're left with centimeters, so we have converted this properly. So looking at this, it's going to be 840 times 2.54. We don't really have to worry about the denominator. So it's just 840 times 2.54. And again, this is a conversion factor, so we don't worry about and we don't use the sig figs here because it's an exact number. We just care about the inexact number. So we're going to end up with an answer here with 2 sig figs. And when I pop that into the calculator, I get a big old answer of 2,133.6. So we need to shorten this guy down into just 2,100 centimeters. Okay. Now, again, and I kind of talked about this a little bit in the notes beforehand. And when we're talking about actual measurements, it does seem kind of silly. Why would we, get rid of these 33 and a half centimeters? Why would we do that? That seems kind of weird. Okay. Why wouldn't you want to keep it as, these? Why wouldn't you want to keep all of these numbers in? Because this seems closer, and arguably it is to a certain extent. The problem is that it does make a difference by the time if this has to be ran through 3 or 4 different equations. Keeping sig figs allows you to stay as accurate as possible, or there's absolutely no doubt what you should have at the end. Because think of it, if you've got you have a wide variety of different scientists that are wanting to test out your experiment. And let's say you want to go by 4. Well, there are others that have better calculators or better measuring tools where they go to like 10, or some go to 7. And so all of you come up with, somewhat similar answers. But in order to be certain, you need to have, super, super strong answers. And that's one of the reasons why, sig figs are important. Okay? It's not so much that we're trying to, fit things in to just get rid of them, or getting rid of things in order for it to fit. It's because things need to stay consistent. Okay, we need to say whatever we use was only this accurate. So our results and our conversions, our calculations are going to be only as accurate as the tools that we're using. Okay, that's what we're saying. Okay, so then we're going to convert two other ones here. So here we've got 2 examples here where we're converting metric units. Thought that would be a good thing to practice, because I know that this has probably confused you guys a little bit, and something that is going to be a little tricky to get used to, which I don't blame you terribly for, but again, these are all important skills to have. So it says here we're just going to convert 5.70 kilograms to milligrams. So we're starting here, and we're converting over to milligrams. So starting here, ending here. Now remember, these are going to be, this is a two-step dimensional analysis here, just like our first one was. Okay, just like this guy was, the inches to miles. We first had to go to feet, and then from feet we then went to miles. Here we got to go to kilograms to grams, and then grams to milligrams. Okay. So we're going to write down what we're given. So 5.0 kilograms over 1, and then our first conversion factor. We're going to put our old units on the bottom, new units up top. Remember, the guy that has the prefix, not the fact that it's on the bottom, but the fact that this is the guy with the prefix, gets the 1. And then we would look on our conversion table to see how many grams there are in 1 kilogram. And there are 1,000 grams in 1 kilogram. Okay? Kilograms would then cross out. We're at grams, but we need to be at milligrams, so now we've got to get rid of these. So we put grams on the bottom, milligrams up top. Milligrams, because it has the prefix, gets the 1. And then, let's see, 1, 2, 3. Oh my goodness. Yeah, that's right. 1, 2, 3, yeah. Okay, and then the number of grams, sorry for the little delay there, the number of grams that are found in 1 milligram, that's 0.001 gram. Okay, grams would cross out, and then we are left with our units of milligrams here. So what this ends up being is 5.70 times 1,000 over 0.001 on the bottom, which is going to give us, if we pop this in our calculator, oops, I did the wrong thing there. It's going to give us an answer here of 5, 7, 1, 2, 3, 4, 5. So 5,700,000. Now, this is an okay answer. But realistically speaking, this should be put into scientific notation since it is above 10,000. So we're going to put this guy in scientific notation here. So it's going to be 1, 2, 3, 4, 5, 6. So our final answer should be 5.7 times 10 to the 6th power, and then carrying our units, milligrams. Okay. Oop, 570. Got to keep those sig figs. So here to rewrite that, 5.70 times 10 to the 6th power. Yeah, because that 0 is a sig fig, so we got to keep that. Okay. Now again, I mentioned this in the notes that if you know the ladder method, if you know it's ladder method or the bunny hop method, That's fine if you know that, if you can do that in your head. But again, what's the most important thing about this is learning this strategy, because you need to know this strategy when we get into to chemical measurements, when we get into actually using this to convert one particular kind of unit to another when it comes to elements, when it comes to compounds, basically so that you can actually measure things in a lab. Okay. And then finally, we're going to convert 20 picometers into kilometers. A ridiculous thing, but we're going to do it anyway. So again, we're starting here. We're going to end here. Okay. So write down our given unit, or given material, I should say, or given value. So 20 picometers. And again, same thing up here. We need to convert picometers into meters. So picometers goes on the bottom, meters goes up top. Pico gets the 1 because it has the prefix, whereas the meters is going to get its little dude here, which is 1 times 10 to the negative 12th power. Okay. And because this is in scientific notation, I'm going to keep this next conversion factor in scientific notation as well. So meters go on the bottom because we need to get rid of meters now. Kilometers goes on top. Kilometers gets 1 because it's got the prefix. And then there are 1 times 10 to the 3rd power meters in 1 kilometer. This is the same thing as saying there's 1,000 meters. Okay, as we saw, up here. Okay, so we're multiplying across the top, multiplying across the bottom. So it would turn out to be 20 times 1 times 10 to the negative 12th power over 1 times 10 to the 3rd power, or again, just 1,000. And so what this would be first it would be 20 times 10. And again, and the reason why I've got 20 here, it's because it's just 1 times 20. Remember, we're ignoring this for a second. Just 2 times 1. Okay, and then negative 12. Okay, and then over this. Oops, and I'm running out of room. And then it's going to be negative 12, which realistically speaking, well, we'll do that at the very end. So negative 12 minus a 3. We're going to go to another page. So then what our almost final answer, we're almost there, would be 20 times 10. So it'll be negative 12 minus 3 to negative 15. But we're still not done yet for 2 reasons. 1, we don't have sig figs, and 2, we still need to move our decimal over. So our decimal's here, just got to move it over once. And so since we moved it to the left, that's going to be adding. That's going to be adding a exponent. So our final answer is just going to be 2 times 10 to the negative 14th power. Okay, because it'd be 15 plus 1. And then if you don't trust that, you can always pop it into your calculator. So you could have 20 times 1 times 10 to the negative 12th power divided by 1 times 10 to the 3rd power. And you get what you expect. You get 2 to the times 10 to the 14th power. Okay? And you have your answer there. So that's dimensional analysis. Again, if you guys have any questions concerning dimensional analysis, you've got to make sure you get a hold of me. This is the crucial set of notes. If you have issues here, you've got to get them hammered and ironed out now, because you are going to have a very, very long semester if you don't get this straightened out now. Okay? So we're going to be practicing this a whole lot. So prepare yourself for a whole lot of dimensional analysis. And hopefully some of you, once you get into that rhythm, it almost becomes not easier, but at least it's so second nature that you actually do find something enjoyable out of it, even if it is just feeling like you're building a puzzle, if you're putting a puzzle together. Okay, that's how I've had other people describe it to me. Is that it's just something they can turn their brains off and they just do it. So anyway. Okie doke, guys, so that's the end of the video. Again, get a hold of me if there's still something you don't understand. If if you're all good, I'll see you in the next one.